See, there is a question in 2025. They ask one question here, that is, in the following graph, ionization enthalpies of successive elements in the periodic table are plotted against the successive removal of electrons. Analyze the graph and predict the elements from the graph. Okay. So for that, they given some options A, B, C, D. Okay. So before going to this, just I want to give a small introduction about ionization energy and electron affinity and electron gain enthalpy. And are you able to see the screen? No, I didn't. I think. Are you able to see the screen? This one? Okay. So in this, based on this particular question, now I'll discuss some important basic points regarding ionization energy and electron gain enthalpy and electronegativity. So okay, now see here. First, if you see ionization enthalpy. Okay, so coming to the definition here, the amount of energy required to remove the electron from the outermost orbit of an gaseous atom. This is what the ionization energy definition. And if you take the equation like when A is in the gaseous state, after removing the electron, it will convert into A plus, and this is also gas. For this, enthalpy is positive because you are supplying energy. Okay, that's why delta H is equal to positive. And coming to the ionization enthalpy units, electron volt per atom or kilojoule per mole. Okay, and in this ionization energy depends on first one, radius increases, ionization energy decreases. You already studied in the chemical periodic properties in the C3COIPL time. Once again, just I'm recapitulating. And Z effective increases, ionization energy increases. Okay, next, for half filled and fully filled, ionization energy is high. Ionization energy is high. Okay. Now, next one is if the principal quantum number same, if the principal quantum number is same, okay, then the energy required to remove the electrons energy required to remove the electrons from different orbitals in the order like S greater than, P greater than, D greater than F. Okay. Okay. So if you see the trends in the ionization energy in the left to right in the period, as well as what you call it, top to bottom in the group. Okay. Suppose if you take 1A, understand, in the periods, otherwise I will explain with in the periods time. Okay, 1A, where is, yeah. See, lithium, boron, beryllium, carbon, oxygen, nitrogen, fluorine, neon. If you observe this, I have written these two elements in a different way. You see, observe this. Okay, because beryllium configuration, outermost electron configuration is ns2, and nitrogen electronic configuration is np3. Means this is helium gas configuration outermost, and this is half fill configuration. That is the reason ionization energy is a bit high. And if you see the order, this is the order, less than symbol. So if you observe, by including the inert gas, neon is having highest IE, highest ionization enthalpy or ionization potential or ionization energy, neon. Suppose if you take again second, third period, sodium less than, aluminum less than, magnesium less than, silicon less than, sulfur less than, phosphorus less than, chlorine less than, argon. If you also observe, same, this is third group and this is second group. Here also same thing. See, third group, second group, same phenomena. Here also, this is sixth group. This is fifth group. Here also, this is sixth group and this is fifth A group and sixth A group. Okay. Now coming to the next period, means fourth period. Potassium less than, gallium less than, calcium less than, germanium less than, selenium less than, arsenic less than, bromine less than, krypton. If you observe in all the cases, if you observe, so if you see this, wait, okay. If you see this, inert gases have high ionization energy, and the underlined elements, see here, there's underlined elements here. Okay, so the trend is not a regular, it is an irregular trend. There's an irregular trend between second A and third A and fifth A and sixth A. Second A, third A and fifth A and sixth A. Because of fifth A elements outermost electronic configuration is half filled, and second A group elements outermost electronic configuration is equal to helium gas configuration. Okay, that is the main reason in this. Here we have you have to concentrate on this. Okay. Next. Next one. Coming to the D block elements, if you consider. Okay. IE. Here, before going to the D block elements, I want to tell one important point. That is, here where the students will use the marks. That is, suppose, so if you take the nitrogen, just now I said because of the half filled electronic configuration, nitrogen have highest ionization energy, right? So if you write down the electronic configuration 1s2, 2s2, 2px1, 2py1 and 2pz1. So each element, see, this is the outermost electronic configuration. So how many electrons are present in the outermost shell? Total 5 electrons. So these are valence electrons. Valence electrons are different. Valence is different. Valency is 3. Okay. So now nitrogen means you can, if you remove the first electron, you already know all this concept, but just in order to solve that problem, I'm giving the small introduction for this. First electron, if you consider, if you remove the first electron, then we can say that IE1. If you remove second electron, and we can say that IE2. If you remove the third electron, and you can say that is IE3. Okay. So as I said, removing of first electron is difficult. Second electron and third electron. So, sir, there is a outermost electronic configuration having that half-fill electronic configuration. So, everyone will write down like IE1 is greater than, IE2 is greater than IE3. Correct? But I am telling to you, when you are finding out IE1, IE2, IE3 of the same element, always IE3 is greater than, IE2 is greater than IE1, irrespective of the stable configuration or helium configuration or any other configuration. Always means if you are comparing IE3 of IE3, IE2, IE1 of same element. If you are comparing IE1, IE2, IE3 of same element, always IEN greater than IEN minus 1 greater than IEN minus 2 and so on. No doubt in that. For any element it is. Not only for a single element, not only for nitrogen, not only for a boron or something, for any element. Okay. Now we'll see the question now. Now see the question here. Okay. So if you see, dotted line represents 1 and green color dotted line, black color dotted line represents 2 and solid line, green solid line 3 and black color solid line is 4. By seeing that, if you observe the ionization energy values, they given the y-axis kilojoule per mole and number of removal of electrons, means first electron, second electron, third electron. If you consider in this, if you observe which line, otherwise dotted green, dotted black, solid green, solid black, which line has highest ionization energy? This one. Correct. So that means here they given some options to you. Correct. Based on that, you tell me this is nitrogen, neon, and phosphorus. Just now, in any period, if you consider any period, okay, and here the first one is nitrogen, in all the cases, nitrogen and phosphorus and neon. If you consider any particular period, neon is having the highest ionization energy because of the inert gas configuration. So by that, we can have some particular confidence, if 30 to 40% confidence, that option might be C. But we cannot leave this, we should move to the second one also. Okay. And they what they mentioned the second is magnesium. Okay. What second means what? Here, black color dotted line. Okay. See now, and if you observe the next one, third one is fluorine, fourth one is correct. So this is sodium, suppose. Third one is fluorine, and this is magnesium, and this is neon, correct. Now if you observe that, just now I told you also here, sodium and magnesium, if you compare, okay, magnesium has high ionization energy than sodium, than aluminum also, correct. So black line should be down, see, but magnesium should be above than this, right? Correct. And what about green line? I think you already know that left to right, what will happen? See the order I given to you, I marked the less than symbol, correct? So left to right in a period, ionization energy increases. But this increases is not in a proper trend, there's irregular trend. For the first, not first, second, third, and fourth element, third period elements. Okay, but whether it is irregular trend also, from left to right, ionization energy is increases because Z effective increases. I hope you all know about this particular concept, Z effective nuclear charge. Okay, Z effective is equal to Z minus sigma, where sigma is shielding constant. Okay, so based on this, we can conclude that option C will be the correct answer. I hope you all understand this question. Now, wait a minute. Now, see here, there is one more question. One more question paper it is. See this. Okay. If you see this one, this is INGSO 2020. Wait a minute, it got stuck. Whatever. Ah, yes. See the question paper. I'll show the starting of this question paper. INGSO 2020. In that INGSO 2020, there are some questions related to the periodic properties that we are going to discuss. Yeah, correct. See the seventh question here. Wait a minute. Now see this. Here, seventh question. Metals reacts with oxygen to form metal oxides. If metals considered as potassium, cesium, magnesium, and strontium, the correct order of basic nature of their oxides. Okay. And here you must know one particular point, that is in a periodic table from top to bottom. Top to bottom. Basic nature of the oxides. Which oxides? Metal oxides. Metal oxides increases. Okay. So that means strongest basic nature containing one, we can say CS2O. Okay, and you know that for the first A group elements, lithium, sodium, potassium, rubidium, cesium. Okay, so K forms K2O and CS forms CS2O. So top to bottom, as I said, basic nature increases. So CS2O should be greater than K2O, right? Understand? And now if you see the second group, second A group, 2A group, that is beryllium oxide, magnesium oxide, calcium oxide, strontium oxide, barium oxide. Here also same thing, top to bottom, basic nature increases. So in that SRO greater than MGO, because SRO here, MGO here. Okay, but left to right what happens? Left to right in the periodic table, basic nature decreases, acidic nature increases. So coming to this, so magnesium SRO will be less basic than K2 and CS2. So my option is C. You got it? Okay. But if you see the option A, option is completely opposite to this. Okay. So seventh question they given in the what? 2020 INGS. Next, coming to the one more question, most important question, which is also related to the periodic properties. In the same academic year they given, that is here. This question. See this. Okay. The year 2019 was proclaimed by UNESCO as the International Year of the Periodic Table, making the 150th anniversary of the Mendeleev Periodic Table, which is an iconic representation of vital tool. Okay, these and all like concepts and all. Now here onwards, most important. Okay, everyone can solve this particular question. It is not that much what you call difficult, but the main thing is reading the paragraph and understanding these alphabets and different Greek letters are most important here. See, in this question, some elements have had their symbols replaced by Greek letters alpha, beta, gamma. That means their intention is instead of lithium, potassium, magnesium, calcium, fluorine, chlorine, bromine, those periodic elements, their symbols are replaced by alpha, beta, gamma, but not in the order. All such elements in this question have atomic number 20 or less. So this is a main benefit for us. Because if they give the entire periodic table like 118 elements, it is very difficult to find out those elements. But they given 20 or less. That means even when you are preparing for this particular periodic properties, up to 30 elements electronic configuration, their atomic numbers anyway they'll give electronic configuration, and even what you call it, they are giving the periodic table also. Okay, just if you learn the 30 elements electronic configuration, you can solve any problem based on this periodic table. Okay, 2025 they given one question, 2020 they given two questions based on this. Okay, now we'll solve the first question here. What is the first question in this? See, elements alpha, beta, gamma are unreactive monoatomic. Unreactive monoatomic. Monoatomic means they are giving the hint, though these gases are 8A group. Beta has the smallest atomic radius. Beta has the smallest atomic radius means they are telling like helium. Okay, of the three. Next, alpha has higher boiling point than gamma. Higher boiling point means higher boiling point for higher mass, higher atomic mass. Okay, generally boiling points and melting points based upon their molecular mass, generally high atomic mass. Okay, so finally we come to know these three elements. What are those? Helium and some particular element have higher atomic mass, correct or not? Okay, so we can say helium and argon. This is argon. Alpha is argon, beta is helium. Obviously gamma should be neon. This is the answer. Okay, now if you see the next question here, the elements delta, epsilon, ohm, xi, theta, x and q exist as diatomic. Most important, exist as diatomic. Okay, and that in the formula like delta 2, epsilon 2 like that. We also know that at room temperature x2 is liquid. X2 is liquid and they said diatomic. That means confirm this is Br2. And Q2 is solid. That means pakka that is I2. and identify the elements X and Q. Over bromine and iodine. Over. You shouldn't write Br2. You should write Br and I. Don't write Br2 and I2. Okay, because they're asking about the elements. Okay, next. They given other hints also, but we can easily find out. Okay, anyway, next question is Xy2 forms compounds with each of the other 6 diatomic molecules. Okay, compounds of Xy with delta, epsilon, and X result in diatomic gases that reacts with the liquid Xy2 theta. That means what is the inner meaning here? Okay, see, Xy2 forms compounds with each of the other 6 diatomic molecules. So what are the other 6 diatomic molecules? Okay, this is over. This is Xy2. This Xy2 reacts with this and this and here and here and this one and this one also. Okay. Now they are telling like in this particular question, they are telling like compounds of Xy and delta and X means Xy and delta. Where is Xy? Delta is, this is delta. Xy and delta, comma, E, epsilon and X. So the reaction between what? Xy2 delta, Xy2 epsilon, Xy2 X result in diatomic gases that reacts with the liquid to form acidic solutions. So what does it meaning? Actually tell me, this is liquid is what now? Acidic solution they said, correct or not? Acidic solutions. Okay, so we already know the some particular elements like CO2. Here, what and all there? Tell me. Cl2O, H2O, okay, NO2, F2O, like that. Suppose. Anyway, Cl2, I don't consider because Cl2 is crossing the atomic number 20. Okay, these are the elements I'm thinking because as per the atomic, atomic number less than 20. So they are telling like when they react with the liquid Xy2O, that means I confirm that this is water. That means identify the elements Xy and theta. Xy is H, theta is oxygen. That's it. And write a balanced equation to show how they combine with each other. Simple. H2 plus O2 gives rise to H2O. Okay. So balanced equation 2 and 2 over. So C over. Right? C over, A over, even B over. Correct? Now coming to the D. D has the highest electronegativity of these elements. D has the highest electronegativity of these elements means pakka this is fluorine because among the 20 elements the highest means entire the periodic table if you consider the entire periodic table if you consider F is the highest electronegative element and CS will be the highest electropositive element. Okay, now see this. By this F2, I found it. The reaction between OM2 and Xy2 is of an immense industrial importance. The product being is a gas that reacts with what happened? That reacts with lipid Xy2 theta. Xy2 theta means you should everything. Xy2 theta means water. Okay, to form a basic solution. Whenever they mention the industrial importance means ammonia, Haber's process, N2 plus H2 gives rise to, not gives rise to, reversible anyway. Ammonia. When ammonia reacts with water, it gives NH4OH, that is basic in nature. Okay. So here by this we found OM2. What is OM2? Tell me now. Here, where is Xy2? Okay. Yes. So by this, ohm is N. Okay, and H you already know what is H, Xi, because I mentioned Xi. Xi means H already. Okay, so once if you will write down all the elements, we get clarity. Xi is equal to H, theta is equal to oxygen. Okay, alpha is equal to argon, beta is equal to helium, gamma is equal to neon, X is equal to bromine, Q is equal to I. Okay. And this is completely related to the next question is paragraph related to the some ideal gas equation that we will discuss the states of matter time, not now. Okay. Now they are given two more questions, that is F and G. Ullal, Manvant, tell me what is your doubt? Yeah, you tell me. Ullal, Manvant. You have option to unmute.
Hello, sir.
Tell me.
Sir,
Ask me.
we have not found out Excel.
No, your voice not audible. Break it.
Sir, we have not found Excel or not.
You are not any
We have
external
not found
knowledge.
extra not Excel or not. E.
X and E.
No,
Sir,
sir, we have not
Epsilon
found
naught.
out E.
Epsilon.
Yeah.
Yes, sir.
Epsilon naught. Epsilon is chlorine.
Okay, sir.
Epsilon is chlorine. Okay. Next, coming to the F. They said this is kappa. We can consider K is more reactive than nu. The stable ions formed by lambda and mu. Lambda and mu means again I need the concept of this. Okay. For this particular concept, I am giving the answer because we didn't discuss this particular question. We should discuss this particular question in the states of matter time. Okay. So anyway, that's why I'm giving to you. Lambda is equal to potassium. Okay. And mu. Okay. This. We'll see this. Wait a minute. K is more reactive than mu. The stable ions formed by lambda and mu in this reaction have same electronic configuration. Then identify the elements K, mu, and we can say nu. Okay. So what they said in this particular thing, K is more reactive than nu. Okay. The stable ions formed by lambda and mu. Okay, what is lambda? Just now I said, what is that lambda? Stable ion, what is what? K plus only. K plus means what? What is the electronic configuration of potassium? Atomic number 19. Okay, so if you see the potassium ion here, 1s2, 2s2, 2p6, 3s2, 3p6, 4s0. This is K plus ion. The stable ions formed by lambda and mu in this reaction have same electronic configuration. Okay, so in the same group, if you observe that we won't get the same electronic configuration, because if you take sodium, you won't get same electronic configuration. If you take rubidium plus even though you won't get any stable electronic configuration. That's why I move on to the another element, that is calcium in 2+. Calcium in 2+ is also same 1s2, 2s2, 2p6, 3s2, 3p6, 4s0. So by this we can consider that mu is calcium. Mu is calcium. And they said K. We already discovered K. What is K? K we have found or not? K.
No, sir.
No.
Sir, it's given in the before page.
In the before page I given.
Sir,
Which one?
hint is there
Where
about
is the
K.
hint? Where?
Sir, last line.
Last line, huh?
No,
I
sir.
didn't check.
Sir,
This page.
yes, sir.
This
This.
page. Where they given this? Then I didn't see any K here.
Sir, we now consider elements kappa, lambda, mu, and nu.
Okay. K, lambda, mu, and V, which are metals that are react vigorously with liquid H2O to produce what? H2 in a H2 and a basic solution. That means these are all metals. Okay, because when any metal reacts with the water, it produces hydrogen gas. So based on that, and they said what here? K. What is the question in this?
So they react vigorously.
Yeah, wait. K is more reactive than mu. K is more reactive than mu in the sense this should be. K we already find out, no?
Sir, no,
K,
sir. We
okay.
not find out.
Sodium. Because more reactive than calcium will be sodium only. Because potassium is already over. Calcium is already over. Okay. The only element which is more than that is sodium, which is more reactive than that. Because other elements are crossing the 20. Within the 20, these are the only things. Okay. Nu is lithium. This is sodium. That's it. Mu calcium. Correct. Mu and lambda is potassium. Because lambda in the stable ion. Stable ion means K plus is stable. Why K plus is stable? Because of octet configuration 3s2 3p6. Why Ca plus is stable? Because of 3s2 3p6. Got it? Now we are going to solve the last question in this particular session. That is, this is also one type of epsilon, sigma, phi are also metals. They don't react with cold water. This particular concept they are given in the NCERT 10th standard textbook. Okay. Which metals will react with cold water? Which metals react with hot water?
Sir,
Which metals
alkali
react with
metals.
steel? Yeah, tell me.
Sir, sodium and potassium react with cold water vigorously.
Not only sodium and potassium, sodium, potassium, calcium also
Calcium.
cold water.
Yes.
Yeah. Magnesium, hot water. Okay.
Hot water.
Iron, zinc,
Aluminium.
aluminium, steel. Okay. Based on that, they do not react with cold water, but react with theta to form epsilon theta and sigma theta 3 and phi theta. Based on that, we can easily find out. Based on, we can say like what the analysis if you consider. If you do the Christoph method for this, we can easily say that is Al2O3.
Sir, phi is magnesium.
And this one, if you consider, these two are secondary group elements because +2 minus 2, because theta is oxygen. See here, theta they given oxygen, correct or not? And they said what you call epsilon theta. Epsilon theta means BeO, MgO. Okay, and identify the element they are telling, like already identified that. What is the, tell me now finally? Sigma, aluminium.
It might be Fe also, no, sir.
But they given elements less than 20. You are forgetting that.
Sir, Sir, psi is beryllium because phi theta contains the largest percentage of theta by mass, which is oxygen. Sir.
That we'll find out. No. First, we'll write down what are the elements. Then after we'll find out the percentage. Okay. Phi and what is the one more? Sigma over, right? Sigma over phi and epsilon.
Epsilon.
Okay. For this. So, okay. Now we don't know which is beryllium and which is magnesium. For that, again, one more hint. That is, phi theta contains largest percentage of theta by mass. So here I'm trying to explain this. I don't have a separate space. See, I'm using here. Suppose you take BeO and MgO. Okay, and they are telling what in this particular question? Phi theta contains largest percentage of theta. Theta means what? Oxygen. Okay, so if you calculate the percentage of oxygen here, what will you tell me? 16 divided by beryllium 9, oxygen 16 into 100. Magnesium means 16 divided by 24 plus 16. Okay, and if you consider in which case the percentage of oxygen is more, tell me.
Sir,
See that by simply seeing only
beryllium
denominator
oxide.
value
Sir
is
will
less
get
here.
64 and 40.
64 and 40.
Sir, because beryllium has a less atomic mass, oxygen will occupy a higher proportion of mass.
Okay. No, okay. No, who is telling 64? Where is 64?
Sir will get 64 percentage.
Yes, sir.
64%. No need to calculate percentage also. Simple. Here, see that numerator value is same, right? Here, if
Sir,
you
it's
observe,
because
denominator value is less.
sir, it's
When
because
denominator
beryllium
value is
atomic
less,
mass is
this
less.
percentage is more. Okay. So oxygen percentage in beryllium oxide is greater than magnesium oxide. Okay. Then tell me phi theta. Phi means beryllium. This is
Magnesium.
okay. Once again, we'll write down these elements here. Those who want, you can copy. Kappa is sodium. Okay. And nu is lithium. And lambda potassium. And mu calcium. And what are the other elements here? Sigma aluminium. Okay.
Sorry.
Next, what is the one more? Phi beryllium. And this is
Epsilon.
also one type of epsilon naught. Epsilon is magnesium. Okay. So these are the questions they given in the INJS for 2020 and 2025. So even I'm expecting one question based on this periodic properties in this academic year. Okay. Any doubts you can ask me in this. Surbab sir. Hello.
Sir.
Hello.
Sir, tell me, sir.
Sir, topic over, sir.
Okay, sir. Students, if you have any doubts, please ask the sir. Already I gave unmute option to all the students. Okay.
Okay, sir, you can wind up, sir.
Okay, sir. Thank you, sir. Thank you.